So it has the in brief the contents about the SD-WAN as a whole. What is SD-WAN? What are the different topics that we would cover under SD-WAN? Okay, so like if you see SD-WAN fundamentals, what is SD-WAN? Why we need SD-WAN? How we implement it, right? How we deploy SD-WAN. So solely we will be talking about Cisco Viptela here. Okay, so we will see how we can deploy controllers. So which is kind of brain for SD-WAN. So how to configure the day zero configurations, day zero, day one, then zero touch provisioning, then SD-WAN policies, operating like runtime commands, how to check CPU utilization, how to check alarms, how to upgrade the software, how we can check which version we have device running on. Okay, troubleshooting like which routes we are receiving, packet drops, CRC errors, duplex, etc. Now this course is split into two parts, basics and advanced. So I'll keep touching both ways, right, depending upon the pace with everyone. Okay, now, in basics, we are covering these topics, fundamentals, in depth, the installation about controllers, cloud, ZTP, zero touch provisioning, plug and play. Don't worry if you are, if you are seeing these things for first time. So the day we will conclude this course, so you will be very much comfortable with all these things, right? SD-WAN, AAA, TACAX, upgrades, DHCP server. So sort of many things we have. We will see. We will go through each and every one. I'll share this file with you. Okay, this PDF which has I'll share with you the ebook as well. Okay, and the lab guides, sort of lab guides. I would say those are not the well written lab guides, but definitely when you go through this course, right, for when you go through the session and then when you refer those documents, you will feel very much comfortable that yes, you can do. Anyway, you would have access to recordings, right? So in advance, we have policies, TLOC extension, and then ACL, traffic engineering, app aware routing, QoS, okay, netting. This multi-tenancy is not part of the design, but I can share with you theory, like how it works, what it is. Okay, so let's talk about. I would prefer maybe we can see what all things you prefer, which way you prefer to understand. Okay, so which way you like. I'll I prefer to do all these things mostly on paint screen so that I can draw real time and share with you the design, the topics, whatever things we are talking about. Okay. So first thing, when we talk about SD-WAN, what is SD-WAN? So it's the software defined wide area network. So basically what we are doing, we are embedding software based things across the WAN. When I say WAN, usually the topology that you see in real-time network, for example, if you are sitting in your office, let's say, if we talk about all of us, we are sitting in this session today, right? So we are connected on the internet line, ISP, right? So I would be having maybe one broadband modem placed in front of me, right, at my house, and you may be having you if you in case you are sitting at X place, you may be having modem. You may have like ILL lease line modem or broadband modem, right? So the connectivity would go like, let's suppose if I'm sitting at my home, for example, if this is my PC, I am connected, let's say wireless or wireline to my modem. Okay. Let's suppose if this is my modem and that goes somehow internet line to one ISP. And let's suppose if you are connected to same provider, same internet provider, you may also be connected via broadband or you may be connected via ILL. So we can definitely talk about the differences between ILL and broadband, right? And the MPLS lease line, let's say, what are the differences? It's key to know that these differences, right? Along with, because this is usual things I talk about when I talk about SD-WAN, like what is overlay, underlay, and then control plane, data plane. Okay, so these are the basic fundamentals that we need to understand before going deeper into the SD-WAN. Okay, so I was talking about the usual connectivity. For example, if you are sitting at remote location, so this is how we are connected. So this is usual connectivity. Okay, but what happens in the corporate environment is like we have, let's say, modems, or if we talk about lease line, right? So what happens in user environment? Let's say there is one person in X organization, let's suppose they are sitting in New York, okay? Another user, let's suppose they are sitting in London. So how they would be connected? Let's suppose if this is their traditional, let's say, I would say router. I'm not talking about SD-WAN so far. So it's just a general topology that we see. Router is connected to, let's say, modem or switches. They go to ISP. There is one router. We have another router. Let's say it's in the New York. Okay. And in London, we also have router. It is also connected to router at that place. So in usual topology, what happens? We have switches in the LAN. So you can just think that this is the usual infrastructure that you may see in your office at usual workplaces, right? So now we have switches, and then in LAN infrastructure, we may have access points, WLCs, for wireless connectivity. There may be users who are connected wireline to these switches. Okay, it may be one switch or it may be 100 switches. Okay, so this is the usual connectivity. You see, this is usual networking, right? So this is, let's say, PC on London. So if they want to talk to each other, if they want to reach to each other, they will go like this. So this is the usual path for two users to interact. Okay. Now, SD-WAN is the software-defined WAN to cater to the, let's say, the requirements of these times, advanced technologies. So software-defined WAN, SD-WAN usually takes care on this network. We are kind of automating, we are implementing the advanced technologies, advanced things, efficient things to handle WAN network on this part. So mainly we will be working on this part. SD-WAN concentrates on the WAN, wide area network. Okay. So SD-WAN, it does not touch this switch or the LAN devices. This part is totally isolated. SD-WAN is not present on LAN side. Okay. So this is kind of LAN. This is WAN. Okay. So software defined WAN, it works on the WAN side. And we have another thing called as software defined LAN, which works on LAN side. The example for this, for example, DNA center or ICE, right? Then we have software defined things for data center. Okay. Kind of ACI you use, that is software defined things for data center. So SD-WAN, LAN, or for data center, these basically they stem from the SDN, software defined networking. Okay. So SD-WAN, SD-LAN, and ACIs, etc., they are all stem from SDN. So the concept of SDN is to separate different planes. For example, control plane, data plane, and management plane. Now, why we want to segregate these planes? For efficient working of the devices. Because if you see in legacy networking, a router, it handles all these planes: control plane, data plane, and management plane. So if you have seen these scenarios where, let's say, your router is capable of, let's say, your router is capable of handling 5 lakh routes. Okay. Now, what happens in case you start receiving 9 lakhs routes? What will happen? This CPU would go high, right? Your data plane, your actual forwarding. Um, sorry, I think somebody is trying to record this session locally, so that is not permitted. Okay. So I just noticed a few other people joined. So I would keep talking about this SDN, and once I'm done, then maybe I'll come back to you and we will talk about what all things we have done so far. Okay. So any questions so far? Anyone? Okay. So if no more questions, then maybe are you comfortable with the pace?
Yes, Amit.
Okay.
I think from my end, I'm okay.
Okay. So anyone, if you have any suggestion, any input, feel free to add on. Okay. For the let's say mates who joined later and could not sync, so I would just quickly recap. SD-WAN, it stems from SDN, the which is software defined networking. The concept of SDN is to separate different planes, control planes, data planes, and management plane. And in brief, if you want to understand control plane, it relates to the routing in traditional networking, just routing, OSPF routes, BGP routes. Okay. Data plane, it relates to the actual forwarding of packets. If you see FIB, or if you talk about PBR, policy based routing, actual forwarding of packets, right? So routing is about receiving routes and advertising routes. Data plane is forwarding the packets by looking at the routing table or looking at the routes. Okay. And then management plane is kind of SSH to the device or telnet, let's say, right? Remotely configuring the device, iOS upgrades remotely, etc. So it's about managing the device. Okay. So in router, in traditional networking, a router, it combines all these planes. All these planes are unified in traditional router: control plane, data plane, and management plane. The concept of SDN is to give a network, is to invent a network which has all these planes segregated. So now with the advent of this SD-WAN, software defined wide area networking, so control plane is attributed to altogether a different device or set of different devices, which is called as vSmart. So vSmart handles all sort of control plane thing, okay, for SD-WAN in Cisco Viptela. And it can be one vSmart, it can be two, or it can be three, depending upon the scale of the network or redundancy design. Okay. But these vSmarts would only handle the control plane thing or the routing information for whole network. Now, end router or end device would not be exchanging the routing information directly to each other. They would simply be talking to each other about the data plane packets. They would simply be forwarding data packets to each other. Routing to these devices would be exchanged via vSmart. Okay. So this is the advantage that we have. Let me clean it up a bit. Okay. So we will mainly talk about here SD-WAN. It stems from SDN, software defined networking. The concept here is to separate different planes: control plane, data plane, and then management plane. Okay. So any question, any queries on this control plane, data plane, and management plane? Because it is very important to understand at this point of time before digging deeper into the SD-WAN.
Amit, if you can just brief us about why we make this planes different.
Yes.
Earlier, we were having everything on the same router. Now we
Yes.
are, yeah.
Yes. So, okay. So why we are doing this? To save the overhead, because let's suppose earlier, if we have in traditional networking, if we have routers, let's suppose, and we are having point to point links, or let's say if we are connected via ISPs, right? If we are having full mesh connectivity, then these all four routers need to know their all LAN subnets, right? For example, if we have switches in their LAN, so if I have subnet 1010 here, and let's suppose on another site I have subnet, I have, let's suppose, 30/30/30/24. Okay. And I have here, let's suppose, 40/24. Now, what happens? Each and every device, this router needs to know 30/24, 40/10 slash, right? It needs to know three other routes. Similarly, each and every device would have total four routes in this topology, but this is what I'm talking about on a lab case, right? On a very small scale level. in production environment, if you talk about the internet routing table, there are more than 9 lakhs routes, right? So what we are, by separating the control plane and data plane, we are saying saving the overhead, the memory CPU capacity of the device. Earlier, let's suppose if we needed a device which had, let's say, which needed, let's suppose 5 gig of memory, now we only need 1 gig. So we are saving the here the memory capacity, the cost related to the memory. Okay, so this is the main point, that is that the advantage that we have with by separating the planes, like we are separating control plane, routing is handled, control plane is handled all together by one device. We are totally extracting the feature of the router where control plane was unified with the data plane. So in case we had issues with the control plane, in case routes exceeded as per the capacity of the device. Let's suppose if device has a capacity to handle, let's say 1 lakh routes, right? And device received, let's suppose 3 lakhs routes. So CPU goes 99%, 100%, and you start seeing the packet drops, right? If you could have noticed in the production environment, when CPU goes high, your data packets are also impacted. But with SD-WAN, what happens? You only get to know about the routes which you really need. You are not receiving the other routes. You are only seeing the best routes of the routing table, meaning we are saving our CPU overhead of the end device, because we will simply be forwarding the data plane packets, actual packets, which users need to talk to each other. Okay. Management plane, when I say we are separating, so there are, let's say, different devices in SD-WAN. If we talk about, for example, there are different devices or different components of SD-WAN of controller. vSmart, it handles the control plane things. So it talks to all the devices. It receives the route table, control plane information for all the devices, and it exchanges with the other sites. So basically, it acts as the route reflector in traditional routing. It receives routes from other devices and exchanges with the remaining devices. Although we can define policies similar to route maps in traditional networking, as we use route maps for inbound or outbound filtering, same thing we can do here with vSmart. We can write a policy to say that which site should receive which route and which site should not receive which route, or on, let's say, X site, if we want to prefer route from DC1, on other site we want to prefer routes from DC2. Sort of all these route decisions, all these complex topologies, customized designs we can use, we can achieve with vSmart. Okay. And then we talk about management plane. vManage is the component of SD-WAN which is handling management plane. Okay. When I say management plane, if let's suppose this is my router which is managed by vManage and it is part of SD-WAN. Okay. So sort of what all things we can do with vManage, we can remotely configure the devices. Okay. We can remotely upgrade. We can capture the statistics, utilization, CPU, alarms, etc. Okay. What all commands we configured, utilization between the sites, what all sites utilization based on the application, right? So we are totally segregating the management plane as well, and that is exclusive that and independent of other components. For example, if the control plane is down, we still have some sort of connectivity to the end device. Okay. In case vSmart is down, our network would still be working. So in case vManage is down, let's say management plane is down, vSmart is still up, so our network would still be working. When we will talk about in detail, I'll show you how what this means when vSmart is down and once vManage is down. We will talk about each and every component in detail, and I'll show you in the lab in real environment, like what happens when vSmart is down. I'll power down vSmart in front of you. You will see everything is going on. I'll shut down vManage. You will see everything going on. And even when I shut down both, then also these devices can keep talking to each other. Okay. Anything, anyone you want to ask?
Yes. Let's say between New York and London, BGP is running. So
Mhm.
you said routing will be managed by vSmart and control will be managed by routers. So can you give me some example of control traffic between New York and London. For
So-
example, can it be like link keep lives or BGP keep lives?
Okay. So you're talking about legacy environment or for the SD-WAN?
In a legacy environment when it is being converted to SD-WAN.
Okay.
So, I guess
So-
BGP will still run between the routers.
Let me show you. So this is, let's say, my legacy environment, and here I'll draw SD-WAN environment. Okay. So now in legacy environment, what happens? We have, let's say, 4 routers. 2 may be connected, let's say, directly, and others may have point-to-point links, right? It is quite possible, this topology, that now, if we talk about, let's say, control plane thing, when you have point-to-point links, right? So you may have this kind of topology. Let's say router 1, router 2, 4. Okay. Now R1 needs to run sort of any routing, be it static, in case we have smaller number of routes, right? But in case we have large routes to handle, large number of routes, then we need some sort of dynamic routing protocol, right? So now,
Mhm.
when you run this dynamic routing protocol, this protocol must be same between R1, R4, R3, and R2, right? There can
Yes.
be different, but for the sake of uniformity or easy handling, we expect that the routing protocol should be same. Okay. Now, R1 would get to know about the routes of R3, right?
Mhm.
And in case you don't want R3 to act as transit, in case, let's say, R4 routes are sent to R3, R3 would by default exchange the routes to R1, right?
Mhm.
If
Not
you,
exactly. I mean, it
yeah,
depends
so
on the routing.
yes, so here comes the overhead that you need someone who is expert with these things,
Mhm.
right? And you need someone who has expertise. What happens if you leave the organization? If you're managing some network and if you leave the organization, you only know that those things, right? You
Mhm.
need some sort of documentation so that the person who is replacing you is aware about all these things, right? And
Mhm.
proportionally, he should be as much expert as you are, right?
Mhm.
So sort of these things, these are complex to manage the control plane things. Now similar things would happen for R2. I'm here taking example of only 4 routers. I have seen similar network for 2000 routers. How many people you need to manage this network?
Yeah, I understand. I
So
mean,
this is the overhead with the traditional networking. Okay. Now we don't have BGP or traditional routing protocol in SD-WAN. Okay. Let's
yeah.
suppose if we talk about similar case of, let's say, 4 sites in SD-WAN. Okay. This is the usual topology, usual design you will see in SD-WAN. Now, let's suppose if this is my vSmart, one of the SD-WAN component, which is part of control plane, which is managing the control plane. Okay. This is vManage, which would be handling the management plane. So you need some sort of WAN connectivity to interconnect to the SD-WAN, right? It would be some sort of, again, router here, okay, for the IP reachability. And now you need end devices to interconnect to the controllers or have some sort of connectivity, IP reachability, okay? So
Mhm.
these are the end devices. They can be Cisco router, they can be V-edges, right? They can
Mhm.
be Viptela hardware, V-edges. They can be Cisco routers. They can be virtual machines on which virtual machines, let's say on premises, or it can be on cloud, AWS, GCP, etc. On virtual machines, we can have images of this SD-WAN devices. Okay, so these are the end devices, and then these end devices, what would happen? Let's suppose if this device, let's say R1 here, it has a subnet, one subnet, let's say, assume. So this subnet would be cascaded to vSmart. Okay. Now what vSmart will do, it is the job of the vSmart to exchange this information with other all sites. This subnet 10.10.10/24.
Mhm.
R1 need not send this information to other all sites directly. R1 just need to share this subnet with vSmart.
So I think I'm a little confused with this. So
Mhm.
there will be no traditional routing protocol running between these setup which you are showing on the right hand side.
Not in this parameter.
Okay.
Traditional
So
routing would be
even the
towards the
IP
LAN.
connectivity will be provided by this SD-WAN system.
No. So far, everything that I'm talking about here is underlay. Except the
Okay.
connections to vSmart. So all these solid lines you see, this is all underlay so far. There is no SD-WAN in this diagram so far.
Okay, so
These are
how the
all,
IP connectivity is being done? I mean, is there any routing protocol already?
it
Or-
depends. If you want to use static, BGP or OSPF, it's up to you.
Okay, so we have to use any routing
But
protocol.
that is only for IP reachability, underlay.
Okay, not
Only
sharing
to reach.
routing.
Yes,
Okay.
so that would be overlay. I'll explain the difference between underlay and overlay as well. Okay. So
So
far,
this is what I was asking. Underlay, there has to be IP connectivity. It does not matter anything static static routing
absolutely,
or dynamic or.
absolutely.
Okay, got it.
Yeah. Okay. So the concept of SD-WAN is to extract this routing handling overhead that you need to, there would be overhead handling large number of routes. So now that is extracted to vSmart. So vSmart is exchanging with the other sites overlay to the existing network or overlay to the underlay network. So if what I'm saying here, overlay and underlay, so it's just that one IP address would be here. If this is my, let's say, R1, this is R2. So for example, if I'm having IP address here, 11.1, and let's suppose having .2/24, right? So this 11.11.0/24 would only be needed, would only be required to exchange using any protocol with other sites, just for the sake of IP reachability.
Okay.
However, the LAN subnets, which would be in the behind the LAN of these devices, there can be, let's suppose, 2000 rights, right? There can be 1 lakh routes. So those 1 lakh routes would be overlay on the top of a IPsec tunnel, which would be formed from R2 to vSmart. We will form, or we can say, this overlay tunnel to vSmart IPsec tunnel from each and every device. There would be one IPsec tunnel, DTLS tunnel, would be formed to vSmart by default. We cannot disable it. It would be enabled by default. Once this tunnel is established, your 1 lakh LAN routes would then be exchanged on the top of this tunnel, inside this tunnel.
Mhm.
Do you understand, everyone? Do you understand how we configure
Yes.
the tunnel in legacy networking?
Yes, I do. Like IPsec or DMVPN.
Yes. Everyone? I need
Yes.
everyone to confirm.
Yes.
In case anyone you have a doubt, please let me know.
I have doubt about tunnel.
Okay. So if you have anything specific, you can ask, or I can explain in detail about tunnel.
I don't have any specific, but I have a lot of confusion between the tunnel which goes underlay. However, it build on overlay. I know that, but
Mhm.
uh,
So if you see on legacy side, on left hand side, legacy,
yeah,
we have, let's say, let's suppose R1 and R2, they are connected via ISP, right?
true.
They can be MPLS private links, or they can be ILL, internet lease line. Okay. Now, let's suppose on this interface, we have IP address 10.10.10.1/30. Here we have .2/30. Are we good so far?
Okay.
Okay. Here, let's suppose we have 20.20.20.1/30. Here we have .2/30. Okay. Now, underlay would be that we can ping sitting on this router using this interface as source. We can ping .2 this IP address directly. I'm assuming we have, let's say, static route or any sort of protocol to exchange this routing information. Let's suppose if this is my interface, gigabit 0/0/0. Okay. On other side, it can be, let's suppose, gigabit 0/0/1. Okay. Now, this is underlay. Now, what would be the overlay? We will configure one tunnel on the top of this underlay. Okay. Would the configuration for this would be, it would be a virtual interface on the router. It would not be a physical interface because gigabit 000, that is our physical interface. Okay. If I want to, I can configure GRE tunnel or IPsec tunnel or DMVPN. Okay. So the concept for all of these is same, tunnel, right? If you could think of the real world, what is tunnel? Something going inside, right? If you think of the tunnels that are being built up at several geographical locations, you see. So in inter-networking environment, if you talk about the tunnel, we will say tunnel source. That is, I can specify IP address or interface. In our case, this tunnel is being sourced from interface gigabit 000. Okay. And then tunnel destination. What would be the tunnel destination? It would be 20.20.20.2.
Okay.
Okay. We are creating an overlay path, virtual path on the top of physical path. Okay. Now, let me show you the difference on in actual. If you see the IP header, if on a router you are sending
destination, we have to give IP address of the other end router.
Yes. Yes. So on this side, on router R2, if you see it, what would be the tunnel source? 001, right? And tunnel destination would be 10.10.10.10.1. Okay. So now, once this tunnel is up, okay, if we talk about the IP header, the packets which travel on underlay from gigabit 000 on R1 to gigabit 001 on R2, if you talk about the IP header, right? So what would be the source and the destination? Can you tell me what is the source and the destination that you expect in IP header? Source IP would be
10.1.
10.1, right? Destination would be 20.2. Okay.
2, sorry.
So there can be ports, source and destination ports, etc. But for our understanding so far, only IP addresses are of concern. Source is 10.1, destination is 20.2. But
why 10.1? Okay.
Source.
So 10.10.10.1 you mean to say?
Yes.
Okay.
And when we talk about the tunnel, this yellow, when we are talking about tunnel, then the IP header for this tunnel or packets traveling across the tunnel, the IP header or the source and destination IP, what do you know what it would be?
From where?
When we are sending packets across tunnel, not underscore traditional path. Or let me clean it up here. Okay. So let's suppose we have switch connected here. Okay. Or let's suppose the user is sitting here. PC1, PC2. Okay. When the traffic from PC1, it is traversing the underlay path. When you see, let's suppose sitting here, you look at the IP header. When packets are, your traffic from PC1 is going to PC2, your IP header, your source IP would be, let's suppose PC1 and destination IP would be PC2. Right? Are you with me?
Correct.
Yeah.
Okay. So this is when packets are traveling on underlay path and we are sniffing, we are taking Wireshark on sitting on the ISP side. Okay. But when we are sending our traffic via this yellow tunnel. When our traffic is traveling yellow tunnel. And when we do Wireshark on ISP side, then what would be the source IP? We can configure IP address on tunnel. We need to configure, in fact, one IP address on this tunnel as well. And it would be, for example, okay. Now the source IP, when packet is traveling inside tunnel, source IP would become 40.1.
Yeah.
Okay. And why we do this? Why we do tunneling?
To make the secure connection.
So one of the reason is to secure the traffic, because now when somebody is sniffing our traffic, they cannot see the actual PC1 IP address, which was the case with the traditional networking.
But that doesn't come under into natting, private and private license, where we
So
can't say.
netting is also one of the way that we can do, but with netting, you can only change the IP address, right? You cannot give encryption.
Yes.
Okay. And that was the one reason when you say netting, I said, and additional is encryption, right?
Yes.
There are other things. For example, multicasting. It is not supported across all. Let's suppose there are certain technologies, those are not supported on the, let's say, underlay path on ISP path, but you
Uh,
can bypass those traffic across the GRE tunnel.
yeah, IPsec do not support multicasting, so
Yes.
that's why we run GRE over
Yes.
IPsec.
So there are certain technological limitations as well. The reason we need GRE or IPsec. I mean, why we really need tunneling?
Tunneling is mainly required when you are connecting your two of the LANs which are distant location.
Yes.
And I mean, if you're not using DMVPN or anything else, then IPsec over GRE, or you get the GRE over IPsec
So
works.
the context here is to simply understand the difference between underlay and overlay.
Yes. So here both GRE and IPsec are
Overlay.
overlay, and your simple routing or connectivity, that is underlay.
Okay. So in SD-WAN, everything is overlay. When you say SD-WAN, you are talking about everything overlay. Okay.
Okay.
Underlay is exactly same, just like as traditional networking.
IP connectivity.
Okay. Whenever you think of SD-WAN, just think of overlay. Everything, whichever is happening, overlay. Okay. This is the comparison when we do between the SD-WAN and the traditional networking. Okay. So that is why I said, I think some of you didn't join, could not join till that time. Underlay and overlay, separation of the control plane, data plane, and management plane. I would not like you, I would not want you to go talk about SD-WAN until you are clear about underlay, overlay, and separation of planes. Okay, take your time. In case you have any sort of question in your mind, just let me know. It is very important to first clearly understand the difference between underlay and overlay and separation of planes. Okay, so if you want, you can create tunnel in your lab, right? You can set up GNS, or you can create tunnels to see how it looks like, what happens. You can maybe, if you want, you can configure a router in lab and you can make Wireshark, you can make captures, right? If you have image for ISR, you can perform like Wireshark sort of captures on the router itself on iOS XE devices. Okay, you can see the difference, that we have advantage with tunnel that our traffic is secure, our actual traffic is not exposed to the, in case there are any hackers or something. Okay, so underlay and overlay in SD-WAN, this is underlay. Even when we are in SD-WAN, we can configure tunnel between two devices. This yellow one which we created here, we can configure between SD-WAN devices as well. But this is explicit tunnel that if we want to configure, but this arrow towards the vSmart is again an example of this tunnel that we configured in legacy networking. Okay. Each and every device in SD-WAN, it would have a DTLS tunnel, secure tunnel established towards vSmart, towards vManage. So what is the use of this secure tunnel towards vSmart and vManage? There is separate control plane path, which would be only for control plane information exchange. Towards vManage, it would be for management plane information exchange. So we are having separate dedicated path for control plane and management plane. In case your vSmart goes down, your network, your devices would keep talking to each other using stale information, using stale routing, which they received few minutes back from vSmart. Okay. Similarly, vManage. vManage is only collecting the statistics of the devices, pushing configuration remotely. So in case vManage goes down, the only problem that we will see that we cannot collect the statistics, we cannot push configuration remotely, we cannot upgrade remotely, just in case we have anything to do. Actual forwarding of packets between these devices, it would happen directly. Okay, so it is a full mesh sort of connectivity. We can control this topology that if they should, everybody should talk to everybody, or everybody can talk to everybody. We can control this, that if R1 should only talk to R2 directly, other devices, they can communicate via R1 to R2. Basically hub and spoke or full mesh sort of topology. Okay.
Yeah.
Yeah.
Anything? Anyone?
So Amit, we can say that all the routing manipulation between R1 and other routers and finding the best path now is being done by vSmart.
Yes.
Okay.
This R1, it cannot decide which link it should go in terms of routing. But if you have worked on PBR, policy-based routing in legacy networking, that we can do, that this R1 device would do in fact. Okay. So this is the another advantage that we have with SD-WAN. For example, if we have, let's say, 2 links from R1, let's suppose I have 2 WAN links. Now, what I want to say that I have my IP phone sitting here. I want to say that any voice traffic which is coming onto this device, it should only follow first link to go to the other side. Let's suppose if this is my first link and this is second link, I can define a policy which would say that any voice traffic that is landing on R1, it should always steer across link 1 as primary path. It should not go to the second path, because by default in SD-WAN, if you have as many number of links, that traffic is load shared across all the links. It is flow based load sharing. Okay. So if you want to statically prefer a path, we can say that voice traffic should always follow first link, because it is quite possible that one link may be MPLS, other link may be ILL. Now, MPLS link would have better performance, better SLAs than ILL, internet lease line, right? So we can, in usual environment, it happens, right? We want voice traffic to follow the best performing link, or link which is having better latency or better performance, right? In terms of drops or jitter. So we can define a policy in SD-WAN to say that voice traffic should always follow MPLS link or first link to go to the other side. And we can say that in case first link is down, it should fall back to second link, or we can say that if first link is down, it should not fall back to second link. Okay. So these are the sort of things that we can achieve with SD-WAN. In traditional networking, you cannot do this. Now, talking about, we talked about why we need SD-WAN, because we are having certain limitations in legacy networking. For example, as I said, we cannot steer the traffic based on the link performance, right? So in case in legacy networking, in case your one of the link is having packet drops, you won't be knowing about the packet drops, right? Until and unless someone complains that, yes, I'm facing issue, there is some problem, right? You will go log into the device, you will see that there are packet drops, you manually switch over the traffic to the other link, right? And for that as well, you need to, let's suppose, if there are in this topology, if there are, let's say, multiple links, right? One link is having packet drop, your traffic would be following one link, right? By default. So if you want that, if there are packet drops on one link, you want to switch traffic to the other link, before switching link, even you need to monitor, you need to capture the performance of all these links to see, yes, it is error free or no. If there are any CRC errors or etc., if link, it would be better if you switch traffic to this link, right? You need to look at the utilization statistics, etc. So in SD-WAN, we can steer the traffic based on the policy that we will write just on day one and sit on chair silently. You need not do anything else. SD-WAN is doing on your behalf. It would monitor the traffic, it would monitor the performance, and even in SD-WAN, you can say that send my voice traffic on best performing link. out of all the available links, you can say that send my this traffic across best performing links at all times. Okay. So this is the advantage that we have with SDWAN, that we can steer the traffic. And since we talked about, we are saving our CPU capacity, so we are saving the cost, right? Because our end devices are now simply forwarding the packets. They need not exchange routing information with the other devices, right? So we are saving the cost. We can remotely push the configuration. Can't we push the configuration remotely in legacy networking?
We can.
Yeah, we can.
Then do you
I
want to
think
guess?
Single plane
depends on many
management.
devices.
Yeah.
So in traditional networking, we can remotely push the configuration, but that is complex. You need to know about the scripting, right? In case
Yes.
if you are doing via Python or, but in SD-WAN, there is something happening in background which is equivalent to Python or Ansible. Okay. TCL scripting or sort of in SD-WAN, it is happening something similar in the background, but we are we are seeing easy to use interface. We are just getting GUI, graphical user interface, where we will make few clicks, we will type the IP address, we will type routing protocol, configuration would be pushed remotely. Okay. And what happens, let's say in legacy networking, if you push configuration remotely from a server, what happens if something goes wrong? If you lose access to the device, what will happen?
You need to send a
Somebody
FE to
required to
reboot it.
reload it.
Yeah.
So in SD-WAN, by default, if you do configuration remotely, by default, it rollbacks the previous change in case the device access is lost after making the changes remotely.
Yeah, this is same as Juniper.
Yes, rollback. Even it is there in iOS XR as well in Cisco.
Rollback in the sense it automatically rebooted or
Yes, not reboot. It would roll back the configuration change only.
okay. If there are any errors observed while
Yes.
configuring.
Yes.
No, a device will look if it will not able to connect back to the network. It will look
Yes.
back.
Yes.
Okay.
By default, 5 minutes or 6 minutes is the default interval. We can change this. I mean, we cannot decrease it, but we can increase this timer. In case your configuration is, let's say, lengthy, it may take 10-15 minutes. So you can increase this timer. Okay.
Yeah, got it.
So because see, whenever you think about SD-WAN, just first think of the limitations that you see with traditional networking. What is the limitation you see with traditional networking, right? So we can remotely push the configuration, right? What else? Cost saving. We can in SD-WAN, we have application recognition, or which is called DPI, deep packet inspection, app recognition. So you can simply say match YouTube traffic and send across my WAN link to. You need not specify the IP address of YouTube server or any application. There are, I think, more than 2000 applications which are well defined within SD-WAN, that you would simply define the name of the application. This SD-WAN box, it has inbuilt intelligence. Okay, SD-WAN code, it has inbuilt intelligence that it would automatically recognize the application. You need not specify the IP address. You can
If we have the SAP application running, we can just mention the SAP there.
yes, yes,
Okay, that is great.
yes. There are many other applications. For example, Teams. You can
Yeah.
say Gmail, O365.
Yeah.
Okay, Facebook. There are my box, AWS, Amazon. There are many things, right? So you can simply say that match YouTube, because in traditional networking, if you want to, let's say, steer the traffic for different applications, then you cannot specify the application, right? You need
Yeah,
to
it's
specify the IP address
prefixes.
for, and
Yeah.
what if that, let's suppose, if for some reason you specified, let's say 50 subnets for Teams application. What happens if Microsoft adds 10 more subnets? You need to change these statically, right? And imagine if you have 2000 sites, you need to make change on all 2000 sites for these 10 subnets, right?
Correct.
But with SD-WAN, it goes, you are still sitting on your chair idle because you have already specified match team.
Okay.
Okay. So this is the another advantage that we have with SD-WAN, that application recognition. So there are many other applications we will see. that and also QS, just like as traditional networking, we have here QS. Okay. Now, in traditional networking, even though we could configure the IPsec tunnels, right? So here in SD-WAN, we have SSL or TLS based tunnels, which are way more secure than traditional IPsec tunnels. So here all paths, even the communication to vSmart, vManage, day zero communication is built up on the highest level of security possible. Okay. So it has highest level of security possible with SD-WAN, which is SSL, TLS based security, or in other words, certificate based security. Zero trust network. SD-WAN network is called as zero trust network. By default, these devices can, if you want, they can ping to each other, but on underlay only. The overlay traffic or your actual traffic, since I said it would be overlay and it would always be secure. Overlay traffic. Underlay traffic, the IP reachability or ping between 11.1 to this IP address, it would not be secure. But overlay tunnel, the SD-WAN tunnel, which would be formed between these devices, it would always be certificate based secured. We will see what is certificate, how these are secure than the traditional networking. Okay. So these are the certificate based secure tunnels. Even the communication to vSmart, vManage. Okay. We can have, just like traditional networking, we can have multiple V-edges or end devices for the case of redundancy, primary, secondary. Even for controllers, we can have multiple vSmarts, multiple vManages for redundancy. Okay. So these multiple vSmarts or vManage, they would be in sync with each other. In case one goes down, other can take over the network. Are we good?
Yeah.
Anything?
In traditional network, when we wanted to move the failover the traffic to primary to secondary, if there are any degradation of service on the primary link, we used to have that IPSLA trackers. But
Yes.
in SD-WAN, we have more granular information where we can capture the particular packet drops, 10%, 5% of packet drops, then we can move the traffic to the secondary.
Yes. We
Or
can
you
define
can,
threshold
yeah.
that in case our packet drops between, let's say, R1 to R2, there is data plane tunnel. This SSL based secure tunnel is established. By default, R1 over on the top of R1 to R2, this yellow tunnel, it by default measures RTD. Sorry. It by default measures RTD, then drops, packet drops, jitter. It measures by default at all times. Based on these parameters, either of them, we can specify an action. In case RTD, in case latency goes more than, let's say, 100 milliseconds, we can define X action. That in case latency between R1 and R2 goes more than 100 milliseconds, do this.
Yeah.
We have things customized. Okay.
And earlier you were saying about the policy, right?
Yes.
If I need to push any DI policy for particular site, we have hundreds of routes in the direct internet access, and I want to add specifically 2 routes for one particular site. Can I do it for the particular site, or do I need to push it from the central policy to all devices?
I'm sorry, I didn't catch your query. Okay, just for the I'm sorry, please
No
just don't take it otherwise. So if you want, can we take this question maybe after the class? Because as I said before, that if we have any out of the course things, we can talk about after the class, just to just to sync the pace for everyone, right?
Correct.
Because since you have worked on DIA, so everyone might not have similar level of understanding, right?
Correct.
Yeah, please don't take it otherwise. We will definitely take it up after the class, right?
Yeah.
Just if you want, just to remember, just paste on the chat. so that we can take up one by one after this session, right?
Sure.
Okay. Anything, anyone, if you have related to this, the content so far? No? Okay. Now, since now we have compared the legacy to the SD-WAN, right? So now I'll tell you the basic steps. What happens with SD-WAN? What are the usual steps? What is the function of each and every device? I hope my screen is visible, right? This is usually in Cisco Viptela environment, you will see these are termed as X edge, where X, it may stand for Viptela. It may be V edge, which is the Viptela hardware. And if you are not clear why it is sometimes called as Viptela and why sometimes Cisco hardware or Cisco Viptela, right? So earlier, this Cisco Viptela solution, this design, this technology was invented by company Viptela. Okay. Then this company was overtook by Cisco. Okay. Initially, to maintain the market flow, okay, what Cisco did, they integrated V-edges into their portfolio. Okay. And they supported V-edges as hardware, as software. Okay. There were codes which Cisco upgraded, for example, X version to Y, Y to Z. Okay. And now no more upgrades. Cisco said, if you want something more than Z, if you have some bugs, some issues in Z, go to Cisco hardware. Your V-edge is of no use. Okay. Now what Cisco has done now, even V-edges as hardware, they are getting end of support, end of sale. They are already. In some time, they would be end of support as well. You won't get any hardware replacement in case you have anything. There would be nothing with for V-edges. Okay. Now everything is on Cisco iOS XE routers. SD-WAN is on Cisco iOS XE routers. Cisco router, which is having iOS XE, for example, ISR 1K, 4K, ASR, etc., right? You can use these Cisco routers as traditional router or as SD-WAN box. Okay. So in case anyone, any company, if they are having Cisco routers they purchased in the past, so they can use those Cisco routers for as traditional router or as SD-WAN box. It's just a matter of iOS XE, latest iOS, and one command which we need to configure to say that now it would be part of SD-WAN domain, or to say that now it would be part of known SD-WAN network. Okay. So these X edges, they can be V edges, they can be Cisco routers. When they are Cisco routers, they are called as C edges. Okay. We can have primary as V edge, secondary as C edge. They are compatible to each other. Okay. Third, virtual machines. We can have white box devices, bare metal servers on which we can run our X edges. They can be Viptela images or they can be Cisco images. Or even we can run these virtual machines on cloud as well, AWS, Google or Azure, etc. Okay. And if we talk about this controller here, this is called as controller, which is controlling the SD-WAN environment. Okay. First is vBond, second vSmart, third vManage. We can have redundancy. We can have multiple instances of each of them. We can have multiple vBonds. We can have multiple vSmarts, or we can have multiple vManagers for redundancy. Okay. Now these vBond, vSmart, and vManage, they have secure SSL TLS tunnels permanently established between them to synchronize the whole network. Okay. By default, even these controllers, they don't trust each other. We need to install the certificate on all these SD-WAN devices, be it end devices, X edges, or be it controllers. We need certificate on each and every device. Once their certificates are authenticated, then only they can start talking to each other as in SD-WAN context. If you want without certificate, you can ping between these devices. That is not a problem, but that is only underlay. Secure SD-WAN path between these devices would be built up on the top of this physical path, right? It would only be built up when certificates are authenticated between all the devices. Anything? Anyone?
No.
Okay. So controller, you will usually see here this word controller, right? These components, vBond, vSmart, vManage, they can be on premises. When I say on premises, we can configure, we can buy a server and we can create 3 different virtual machines at least, and we can configure vBond, vSmart, and vManage on our own server. Okay, they can be on AWS, Azure, or GCP. For example, it can be on clouds as well. It can be on Cisco cloud. When I say Cisco cloud, then it would be managed by Cisco only. When we are having on premises on our own server, then we have freedom to manage it by ourselves. We would do everything starting from day 0 setup of all these devices. At least for controllers as well, we can have like this, that controllers are hosted on Cisco cloud, managed by Cisco, and these end devices we are managing by ourselves. Okay. Now, what is the role of and again, these vBond, vSmart, and vManage, they are always virtual machines. You cannot say that I am now going to buy one vSmart hardware, just like router. vBond, vSmart, vManage, they are always virtual machines. There are certain configurations for these devices that we need. For example, if we buy a laptop, we say I am buying i5, would be the processor, right? This is the CPU, this is the, let's say, memory, hard disk, that would be, right? RAM, etc. Sort of similar things would be there for these all 3 components, vBond, vSmart, and vManage. There are certain minimum requirements that vManage virtual machine, it should have this much number of CPU cores, this much hard drive memory, etc. So we can see, we can look at the data sheets to check what are the minimum requirements in case we want to set up controllers on premises. Okay. Okay. So we can have, let's say, as I said, for redundancy, we can have multiple vBonds, multiple vSmarts, multiple vManages. Okay. There can be multiple WAN links as well. For example, if I say our controller is having 2 links, this device is also having 2 links. This is, for example, ISP1. This is ISP2. Okay. There can be multiple links, and the connection to controllers, I will explain. To vSmart, at least it would be one connection, one control connection to vSmart via each WAN link. Okay. So these are the virtual tunnels. In colors you see, these are all overlay or virtual tunnels. If you see black solid line and this blue solid lines, these are physical underlay path. And if anybody is not clear or having any doubt, so this is just, it would be a gigabit 000 interface, for example. When I say physical, here also it would be some sort of interface. We will configure IP addresses on these interfaces here. Just like traditional networking, IP address XXXX. Here also it would be some sort of IP address. And as I said, in legacy networking, as we talked about the overlay tunnel, right? Between two devices, for example, in SD-WAN, this overlay tunnel, we are not configuring, we are not saying tunnel destination or tunnel source. It would automatically recognize the tunnel source and the destination. Okay. Okay. So now, if we talk about the functioning of each and every component here, by default, each and every device, this V edge or C edge, right? They have certificates inbuilt into the device. Okay. So X edges, V edges, or C edges, they have certificate inbuilt in the device for the purpose of security. Okay. Also, these V edges or C edges, they have two things, for example, serial number and chassis number, just like additional level of security. If in case somebody, let's suppose, hacks or something happens with the serial number, we have chassis number as additional parameter for security. Okay. Now, if we talk about the basic functioning of SD-WAN network, how it happens, our X-Edge1 device, right? If I say I have configured some IP address here, at these points, these interfaces, I have some sort of IP addresses configured. Now, these all IP addresses should be reachable to each other. They should be able to ping to each other. Okay. Are you with me, guys?
Yes.
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 So by default, or before onboarding into SD-WAN, all these devices, the prerequisite is that they should be able to ping to each other. Okay. Now, assuming that these devices, they can ping to each other as part of the initial configuration, or one is zero touch provisioning. We will talk about it as well. If we say this access device at minimum, it must know about the vBond IP address. On XH1, this is the syntax of the command where I say vBond and then IP address of the vBond. This is the physical interface IP address of the vBond which is connecting to the router here. This interface IP address. The IP address here would be, okay, this XH1, it must have some sort of routing, be it default route, be it via dynamic routing via ISP, it should be able to ping this IP address. Okay. Now, instead of this IP address, we can type here domain name as well. Or we can type here multiple vBond IP addresses as well, like this. vBond 1.1.1.222.333. So it will by default then try to reach on, in case there are 3 IP addresses, so there would be 3 vBonds here. Okay. It would be 222 would be the physical IP address of second vBond. 333 would be the IP address of third vBond. Okay. It would choose randomly to go to the either of the vBond. We will come over the reason, the purpose of why it would go to vBond. Okay. Now, we can use domain name. This domain, let's say it can be mapped to one IP address or multiple IP addresses, right? This XEdge should be able to resolve this domain to the vBond IP address. Okay. Now, why we need to go to vBond? vBond is the first point of authentication. Okay. vBond is first point of authentication, or you can say it acts like a firewall for all the devices which want to onboard into the our SD-WAN fabric. This is controller and edges. They are conclusively called as SD-WAN fabric. Okay. So let's suppose if this XH1 and XH2, they are still not connected via our SD-WAN network. They are not yet integrated to the SD-WAN fabric. They are still all are acting as the standalone devices. Okay. The very first step this XH1 would take to integrate, to add itself into the SD-WAN fabric, it would initiate a DTLS tunnel to VBond. First point of authentication, that each and every device. So this XH device, which it would initiate DTLS. DTLS tunnel and TLS tunnel. So DTLS and TLS, they both are SSL based, certificate based secure tunnels. Okay. So DTLS is UDP based and TLS is TCP based. Okay. So although this is UDP, this is TCP, we know in TLS, which is TCP based, everybody knows that in TCP there is sort of sequencing, acknowledgements, right? Retransmissions, etc.
Yes.
Even DTLS based security with UDP, even it has its own way of sequencing, etc., or to know that which packets are received or missed. So some sort of TCP functionality is also built up with DTLS. Okay. So this is just, if you want to know, you can try to understand on high level that it also has some way to identify the sequencing, etc., that which packets are received and which are missed. Okay. So when this XH device, it initiates a tunnel to VBond to integrate into the SD-WAN fabric, it would carry its serial number and certificate. Serial number and certificate. These are two parameters which would be used to find out that yes, this is authenticated device which is trying to integrate into our network. Serial number, we need to whitelist in advance on VBond. Let's suppose if we are expecting 500 devices to onboard into our SD-WAN network, we need to whitelist in advance 500 serial numbers on VBond. I'll show you on VBond how we can see which all serial numbers are whitelisted, but we need to say it in advance to tell to VBond that these are the serial numbers that you may expect connections coming in. Okay. Now, serial number, already we have there, it is whitelisted. If it matches, first level passed. Second, certificate. This device would have certificate, VBond would also have certificate. In case their certificates matched, on high level, if you think of certificate, you can just think of hashing or keys. It has encrypted keys or hashings. So in case these hashings or hash keys, modulation things, if they match, then only this DTLS tunnel would be established between XEdge to VBond. So this is why we say that SD-WAN is secure. How it is secure? It is using certificate-based security, and we are whitelisting serial number as well. Are we good?
Yes.
Anything, anyone? Okay. So this is, as I said, first point of authentication. Now, assuming serial number is whitelisted, certificate is exchanged, authenticated, right? It would form a SSL based or DTLS based, UDP based tunnel to VBond. Okay. It has fixed set of port numbers which would be used for this tunnel 1, 2, 3, 4, 6. This is the port number which would be used to form the tunnel to VBond. So if you have seen the regulatory issues with, let's say, China or let's say Russia or Middle East, right? You might have seen that IPsec packets are, you can say, sniffed or dropped filtered, right? So certain
I think
IPsec packets, sorry.
I think we cannot take out any IPsec data from China, at least. They
Yes.
do not allow.
So it happens similarly with Russia as well as Middle East, right? Certain countries in Middle East as well. So IPsec packets are filtered. So if you are sending, let's say, IPsec packet between two routers, let's say on port number 500, they will definitely be monitoring your traffic and it would definitely be filtered. Okay.
Yes.
So what happens in certain country in Middle East, even if they filter your traffic intermittently, they would start dropping your all 500 port number traffic for, let's say, 2 days. Okay. You cannot make your tunnel up in those 2 days. So what happens to overcome similar things, right? What Cisco or Viptela they did, they created a port hopping thing that it would, this tunnel, let's suppose if it did not come up on port number 12346, it would port hop this number by number 20. Next time it would try to build tunnel on this port number. It would increase the port number by 20. If it did not come up on 12366 as well, it would try on 386. Next 12406. Okay. After these 5 iterations, it would again come back onto 12346.
Okay.
Okay. So this is, I still only talked about the DTLS tunnel, first point of authentication, that VEdge would initiate one DTLS or UDP based tunnel to VBond using serial number and certificate as the whitelisting thing, right? On these port numbers, once this tunnel, this yellow tunnel, it is temporary tunnel. Okay. Now this VBond, it is also called as orchestrator. Everybody, do you understand the meaning of orchestrator?
I guess yes. I mean
So
something with
Yes, it's like eagle eye.
yes, so the role of VBond is to help other all devices talk to each other. VBond is kind of firewall which is sitting in the front end. Okay. Once this DTLS channel is established to VBond, what VBond will do as part of the initial day 0 configuration, we are expecting, or you can say, when we are setting up our SD-WAN network, we first need to set up these controllers. VBond would vmanage, vsmart, and VBond. They would be set up at first point of time. Okay, as a first thing. Once these are set up, there should be DTLS or TLS tunnels established between them as well, as part of the initial configuration, as part of the controller setup. There would be tunnels established between them. They would be in sync with each other. They all must have certificates exchanged between them, certificate authenticated. Then only there this TLS tunnel, which are TCP based tunnels, would be established between them. Now VBond would know about vSmart serial number and vSmart IP addresses, WAN IP, right? Similarly, VBond would know about, they would go, we even on vmanage we need to specify like this, the IP address of VBond. So even as part of day 0 configuration, we need to tell to vSmart and vmanage about the VBond IP address. Just like vEdge or Xedge, they would also initiate TLS tunnel to VBond. Okay. So once these tunnels are established, now VBond knows about the vSmart IP address, vSmart serial number, vSmart certificates, right? Now, since VBond knows about the vSmart and vmanage details, the job of vSmart is to share the details of vSmart serial number, IP address to Xedge. On the top of this yellow tunnel, VBond would share the IP address as well as the serial number of vSmart and vmanage, both would be exchanged with Xedge. Now, Xedge would know about that, yes, let's suppose 111 is the serial number for vSmart, 222 is the serial number for vManage plus the IP addresses of vSmart and vManage. Now, what would happen now? Now, vEdge or xEdge, it knows about the IP address and the serial numbers of vSmart and vManage. Now, xEdge would initiate TLS or DTLS based tunnel to vSmart and vManage. This is again overlay tunnel on the top of this physical underlay path. This is virtual tunnel, overlay tunnel. It would be enabled by default. We need not do anything in this. We just, for all these things, we just need to make our certificate setup and we need to define the vBond IP address. Now, vBond has shared the details of vSmart and vManage to xEdge. xEdge would initiate now tunnel to vSmart and vManage. Okay. Again, their certificates would be exchanged for the purpose of security. If their certificates are exchanged, they are authenticated, then secure tunnel would be established between vSmart to xEdge and vManage to xEdge. Now, the tunnel to vBond would be terminated. As I said, it was a temporary tunnel. The role of vBond was to only exchange the details of vEdge with vSmart and of vSmart and vManage with xEdge. Are we good?
So to build the communication between vSmart and vManage
Yes.
and edges, that's it.
Yes, yes.
And it's a temporary link, right?
Yes. That is why vBond is called as orchestrator. It is orchestrating the connectivity across all the components.
And I have one doubt about vBond.
Mhm.
Like, will it maintain backup of all the edge devices and as well as vSmart and vControl? If at all we are losing vSmart and vManage, can we able to roll back from vBond to again to vSmart? Such I
If you
just
talk, if are you talking about backing up the configurations?
yes, not configuration, connectivity. Means vBond having all the information about edges and vSmart and manages.
Yes.
So does it helpful to backup?
So when you say backup, if you are not talking about the configuration backup, what other things do you think we should backup?
Same configuration or control, like
Configuration management plane.
control plane.
vManage is the owner of management plane. Everything is backed up here on vManage. Configuration backups.
Okay. So
Over on the top of the
okay.
control connection to xEdge from vManage. Everything which is part of management plane is happening on the top of this control connection. The tunnel, DTLS or TLS based to vBond to vSmart or vManage is called as control connections. You will frequently hear about, see about whenever you will talk about SD-WAN, you will get to know frequently about this thing, control connection, because our everything to controller is part of control connections, right? Everything between directly between xEdge 1 to 2 is part of data plane here. This is data plane. Towards controller vSmart, it is control plane. Towards vManage, it is management plane. Okay. So I think we are already overrun by 10 minutes. I was informed that the session would be till 10:30 IST, right? So if everybody okay, I can continue, or if you want, we can take up questions and we can continue tomorrow.
Okay.
As you say.
We can continue tomorrow.
Yeah, that's fine. So anything so far anything about things we talked about today, anything you have in your mind you want to ask, or anything you want to, I mean, comment about the content or pace of the course? Because see, my ultimate goal, there are commercial things aside, right? Money related things. So my goal is that for you, everybody, to understand what is SD-WAN, why we really need SD-WAN, right? Of course, we will be digging deeper into each and everything. My goal, my purpose here is to that you are clear about SD-WAN, right? The things we have talked about today. So on daily basis, on throughout the course, just go explore on, let's say if you want, on Google or somewhere, right, on blogs you want to go, you want to read about, right? If anything you have about the content or paste, just let me know.
Amit, can we get topics for tomorrow so that we can make little bit study on that?
Yeah,
And
sure. I can give you this link. See, ebooks ebook is a separate thing, right? I mostly prefer using this Cisco, this URL or Paint or the PDF that I have. So yeah, one more thing. What you can do, I think everybody, you can paste your email address on chat. I can share with you the documents, right? Ebook or the lab guides and all those documents, right? One link I just shared on chat. This is Cisco Live document. If you want to refer, I would be taking up most of the things tomorrow from this document only. And also, I'm sharing with you a DMVPN link for INE. I feel I usually refer that link. So it's helpful to understand. So in case you go through that link and if you are clear with this, so it would be easy for you to understand how things are happening, right? In the background of SD-WAN, right? So that is somehow related. It is not exactly same, but the link I'm sharing on chat for DMVPN. So up to some extent, yes, it is related.
okay.
So I have shared links on the chat for Cisco Live document and one INE blog for DMVPN. If you are already comfortable with DMVPN, then I think it would be easy for you to go through. I mean, it would be just like a revision, right? But
Yeah.
in case you haven't worked or talked about DMVPN before, then it might take some extra time for you to understand, but it is very helpful. Even if you talk about SD-WAN or about general things. So I only got 4 email addresses, right? So we have, I think, 5 people. Nitin, I got. Imran, Ajay. Ajay, did you already share your email? Okay. Anyways, now we can we can take up the. I think somebody you were asking about a few things, right?
Amit,
Yes.
this is Mohammed. I actually wasn't late. So there like any way to get like a recording session?
Yes, I think this recording would be uploaded onto your account, that the account details you would have received on your email, right? If you have already enrolled, you would
Mhm.
have received your login to networking's portal and their recording would be uploaded.
It will be uploaded in within an hour or 2 hours, do you think, or it will be uploaded tomorrow?
I think it would be tomorrow, but you can check with support team in case there is any change.
Okay, no problem.
Okay.
Sounds good.
Yeah, welcome. So if you still see my screen, anything you have related to this, you can ask, or maybe if not, then we can take up the queries, right? Somebody you were asking about the policy.
Let me go through the like a session. Probably
Yes.
because so many things I miss it. So but I cannot ask you like randomly right now. So it will be like embarrassing if I ask anything.
No
So yeah,
problem. Feel
let me
free to
look
ask.
first, then I will ask it tomorrow.
Okay, that is also fine.
Amit,
Thank you.
say there are 10 sites which we are integrating with this new SD-WAN setup. Once everything is set up, this vBond will be sitting idle until
Yes.
a new site is being.
Yes. Yes,
Okay.
yes, absolutely. Now, not you can say yes, kind of idle standby, but in case, let's suppose your one of the WAN link on one side goes down. Once this link comes back up, then again there is role of vBond.
Okay.
Then again
Or
it
we are
would do similar thing.
replacing bad hardware even in that.
Yes, 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 absolutely.
Okay.
Good. So I think somebody you were talking about DIA, right?
Yeah.
Yeah. Can you tell me now your query?
Query is like I have 2 subnets to add for particular site that is into DIA policy.
You mean 2 subnets for source or for destination?
Destination.
Okay.
And what I got to know that DIA policy need to be pushed from the central policy.
Yes.
And it will be pushed to the every devices in the network. Can't we push only for the particular specific site?
Yes, we can.
We can do that, right?
Yes.
Okay. Then
And
I have misguided them.
maybe there could have been different contexts, right? So because the thing that I'm answering now is up to my understanding that you're saying that you have dia policy and you wanted to configure for one site, not for all the sites. We can do that.
Correct.
But when you're saying two specific destinations, right?
Yeah.
Two specific destination, because when you say dia, it is source. Yeah, we can. Yes, yeah, we can do that.
Two specific prefixes.
Yes, we can do.
We can do it.
Yes, absolutely.
And that can be pushed for the only particular site.
Yes.
And the same need to be done under the central policy or?
Yes. So it can only be done via centralized policy.
Okay.
Yes.
Got it. Yeah. Thank you.
Anything else? Yeah, no problem. Anything else, anyone? I have got your emails. Okay. Then I'll share with you the ebook G Drive link. Okay. Ebook G Drive link would be there, and then lab guides. And this, of course, this PDF that we saw in the starting, right? This PDF as well, I'll share with you. So you can reply on the same email in case you have any query, any question. Okay. Yep. And also, I have something like going on. Maybe starting Monday, we can create WhatsApp group as well. So in case there would be any questions, query, if you have from maybe your real time working, if I would be able to answer, I would be more than happy to.
Yeah.
Okay.
Okay, then. If nothing else, then maybe we can hold for today, right?
Thank you. Take care.
Yeah.
Thanks.
Thank you, everyone. Thanks. Bye-bye.
Thank you.